So sometimes you might want to declare interfaces where not all of the properties are required. And this pattern comes up when you're creating functions that, or when you're passing objects where not all with only a few properties. So let's say we wanted to create a function that registers a student for a school. So we're going to call this type info, and it's going to do some register. Up here, let's create the info type, and this is going to have a ID, a name, and let's say the caller of registered student, or let's say the type of info can optionally have a favorite color. The way we create an optional property is with the question mark keyword. So if I call register student with an object that has an ID, a name, and a favorite color, that's going to work fine. But we can also call it as well. Let's say this is Joe. We can call it as well without a favorite color because favorite color is optional. As I mentioned before, you often see optional properties when working with configuration options and stuff that's optional. So let's say the return type of registered student will always return favorite color. So I'm just annotating the return type of the function like so, and I'm doing it inline. So ID is a number, name is a string, and the favorite color is a string as well. And this is saying that the return type of this function will be of the shape of this. So then I can create a new student, and I'm going to say that the ID is the same as info ID, and that the name is the same as info.name. And we're going to start off initialize the favorite color to none. And then after, we can do a check to see if the favorite color property exists on the info object, then we will assign it. Favorite color equals info.favorite color. And then we will return our new student, and there we go. So then if we go out here and say student A and student B, if we print out the two, let's go into our terminal and let us compile this. And then run the JavaScript. We can see that the first student that we pass in a favorite color is properly initialized, properly created with a favorite color green. But the second one doesn't have a favorite color, and that's because the second student, when we created it, when we passed the second student sign-up information to the function, this if statement did not catch because there is no favorite color, because favorite color is optional, and that's okay. So there's also behavior that Typescript provides that's similar to excess property checking when working with objects where all of the properties are optional. Let's say I wanted to create a function that makes a smoothie, and this is gonna options, yeah, and it's gonna take in some smoothie options, and it's gonna make a smoothie. And here I'm going to create smoothie options with all of the properties optional. So let's say I wanted to pass in blueberries. Whoops, berries. Boolean. Let's say strawberries. Boolean. Nut butter is Boolean. But all of them are optional. So if I wanted to build a smoothie or make a smoothie, I can incrementally create it. So I can say let smoothie, and I can assume everything is false at first. There's no blueberries, there's no strawberries, and there's no nut butter. And then in my code, in my function, I'm going to check if for each option in the smoothie options, if it exists. So if options.blueberries exists, then I will set smoothie.blueberries to true. And of course, I can't spell. And I do the same thing for strawberries and nut butter. And then I return the smoothie. There, boolean. We call types that are similar to smoothie options, where all of the properties are optional. They're called weak types. And the reason why they're called weak types is because technically, with structural typing, we could pass in an object with anything, right? If we have an object that, let's say we pass in an object with, I don't know, random stuff, right? Foo, bar, these are just random things. We could pass in, this object technically is a smoothie options because it has excess properties, but according to duck typing, structural typing, these are all optional, right? So does that mean we consider this as smoothie options? And Typescript says no, we don't. So we can pass in an empty object. That's, I think, the one exception. But if we try to pass in an object with an excess property like this is similar to excess property checking right now, where we have an extra property as an object literal. But the thing that's different with weak types, where all of the properties are optional, is that it also performs this check even if you're not passing an object literal, even if you create the object beforehand in a variable. So if I say options equals this object where the mango property is true, if I pass in options, we're going to get a type error, whereas before we didn't. And this type error, where is excess property checking, Typescript performs excess property checking even when you're not passing in an object literal, only for types that are weak types. So one thing to note when working with weak types. The last thing that I wanted to go over is something called the read-only modifier that you can use to modify properties. So let me give you an example to show you why you might need read-only. Let's say I have a function, I'm just going to call it foo, and it does something with a student. And the shape of the student type looks something like this. It has ID, and it has a favorite color. And this is going to be a string. So if I pass in foo, and if I pass in a student to foo, let's say I want student, and this is going to have an ID of 123, and not the name. Favorite color is going to be green. I can pass this student into foo, and in foo, the problem here is what happens if I change the ID to 456. That's something that really shouldn't happen when you are working with students to change their ID. Usually their ID is created when the student is registered or something, and it never changes after that. So if let's print out student after the function gets run to see what happens to the ID property, see if it's changed or not. Let's open up the terminal and we'll clear this. We'll compile our Typescript to JavaScript and then run it. We can see indeed that foo is changing our ID property when in reality it should not. So to prevent this, we can add the read-only modifier on ID, and as you can see, right when I added this, we get a type error saying that we cannot assign to ID, we cannot change it or mutate it because it's read-only. So read-only is great for when you want to avoid mutation, and mutation is something that not a lot of people like, and that's why a lot of people enjoy working with functional programming paradigms. And yeah, so read-only prevents stuff like this. And of course, favorite color is something that we should be able to change. And that's okay because it's not read-only.